Algebra 2, Lesson 54, Polar Coordinates and Similar Triangles. Alright, starting with polar coordinates. This is a fun lesson. So we have to change 28 angular 310 degrees to rectangular coordinates. So first we're going to start off with the angle of 310. So we'll kind of construct a loose graph here, and we'll kind of count our degrees. So starting from here, we go from 0 to 90, 90 to 180, 180 to 270. So 310 is going to be somewhere in this quadrant. All right, and now we have to find the rectangular coordinates, and then our angle is going to go out to a length of 28. So we have to use rectangular coordinates to express the lengths of the sides of this triangle here. So we got to find our x value and our y value so we can express the exact same distance and direction using rectangular coordinates. To do that, first we have to find this inside angle of the triangle. So if this was 310 and we know there's 360 in a circle, then this has to be 50 degrees. So we just find that degrees by going to the very next line to figure out our triangle. And then from there, we can use our hypotenuse and our angle. We can use our SOHCAHTOA identities to find the adjacent side, or x, and the opposite side of y. So we're going to be using our sine and our cosine identities because they both use the hypotenuse. So for this equation, to find the adjacent, we'll start with the opposite since sine's easier. So we would have sine of 50 is going to equal the opposite of y over the hypotenuse of 28. And then we would have the cosine of 50 would equal the x side over the hypotenuse of 28. Once we solve these, we'd multiply each one by 28. Those would cancel, and then we get 28 sine of 50 equals y. Here we multiply by 28 again, and then we get 28 times cosine of 50 equals x. So from there we just go to our calculator, because this is a trigonometric problem, and we're going to type both of these in. Let's see if I can get some more light in here. That didn't help. Okay, so we'll start with the sine 28 times the sine of 50 in parentheses, and then we get 21.44 or 21.45 if we round it. So y is going to equal 21.45. And then let's do the x, 28 times the cosine of 50 in parentheses, and we get 17.998, or let's see here, that would actually round up to just 18 even. So that's going to equal 18.00. Now, to turn this into rectangular coordinates, we have to put it in terms of I and j. Or, you know, actually I think your book uses left and right and up and down. Let me check. Yep, that's right. Algebra 2 uses up and right, and eventually you'll start representing rectangular coordinates in terms of I and j. But for now, let's think of it in terms of right and then up and down. So if we go 18 on the x-axis, that is a positive right value, so that would be 18.00 r, and then we have 21.45 on the up axis or the y-axis, and if that's not going up, that's going down, so that would be a negative up value. So we do 18.00 r minus 21.45 up, or u. All right, so if it went left on the x-axis, it would be negative 18, but it doesn't, it goes right, or it'd be negative r. So just remember, if we go left, that's negative r. If we go right, that's positive r. If we go up, that's positive u. If we go down, that's negative u. And that's how we find our rectangular coordinates. Now, this could also be done if you chose to use this triangle as well. So if you wanted to figure out this degree here, which would have been 40 degrees, you could have done the exact same method on this triangle. The only thing that matters is you have to go to the nearest leg of your unit circle or your graph. So just go to the nearest axis, and then either one of these triangles will both give the exact same answer. Now, similar triangles. We'll look at the problem in the book. So they give us this circle. They say the two triangles in this figure are similar, and we have to use the length r, s, t, and v to write a proportion. Then we have to solve for r in terms of s, t, and v. So let's figure out these similar angles we've got here. Now, we know that these two angles are equal, and these arcs tell us that these two angles are equal. So the similar sides would be S and V, and then R and T. Those are both the similar sides of the triangle. So we could say that R is to S as T is to V. From here, all we have to do now is solve for R. So to get R by itself, I'd multiply each side by S. That cancels, and then R equals T times S over V. And that's our answer. Just TS over V. Really simple. The hard part is figuring out how to write the proportion and then figuring out which sides coordinate to which sides in the triangle. So you can use some of your geometry knowledge to help you out there, and then you could also, even just using only these angles that they gave you, you would be able to figure it out as well. Alright, that's all there is for today's lesson.